So we have a mixture of 3 organic compounds dissolved in an ordinary organic solvent. We know this solvent to be diethyl ether. So we have an acid, a base, and a neutral compound that are dissolved in that diethyl ether. So we have salicylic acid, we have quinculadine, and then we have camphor, which is neutral. So diethyl ether is actually lighter than water, which is a rare case where the diethyl ether will form the upper layer, constituting the organic layer. And just below that layer is the interface that separates the organic layer from the water layer, and below the interface we have our water layer. So we poured our mixture of our 3 compounds and our diethyl ether into the separatory funnel, and we added some sodium hydroxide and we inverted it. And now we have our couple of layers. So since we added our sodium hydroxide, our acid is going to be in the water layer because we took off that hydrogen, which gives the acid a charge, and now it will stay and mix with the water, whereas before it was in the organic layer. So this is going to be where the salicylic acid is, and the camphor and quinculadine is in the top layer. So now we are going to drain these into their appropriate layers. So let's start with the bottom one, our water layer. So we drain this, and this is going to contain our conjugate base and water. And then our top layer, our organic layer, is going to contain our base and the neutral compounds. So as we drain the organic layer, we have the interface we need to worry about. And the interface is a small liquid portion that actually consists of where the 2 liquid phases meet. So the interface is actually going to go out with the organic layer. So we'll drain that out with the organic layer. And it will be used over and over. So now we are going to do another round of adding some more sodium hydroxide. So let's add that base to the organic layer. And then we're gonna mix it around. And then we're gonna add it back to our separatory funnel and get another 2 layers and redo that process of draining out each layer. And then we'll be left with our water layer and organic layer. Now we need to recover the acid. So we take our conjugate base and we're gonna put it into an ice bath. And then we're going to add some hydrochloric acid. And a precipitate is gonna form as we're getting that original solid acid back. So now, once we get that permanent solid, we're going to test the pH. So we want a pH of 1 or less. So we're going to take our stirring rod, dip it into the mixture, and then we're going to touch our pH paper rather than take the pH paper and dip it into the mixture. So we're looking for a red. So now we have our crude acid, and we can go on to recrystallization to get those pure crystals. So we have our crude acid, and we're going to put it onto a hot plate. And we're going to bring it to almost boiling point so that it heats up and we can dissolve those solids back. So we can add water if necessary to dissolve those solids. So now our crystals are dissolved and we're all good. There's just the liquid. We just have our salicylic acid, and we're going to take it off the hot plate. And we're going to let it cool down and let those crystals start forming. So after a long length of time, we have crystals now. So now all we have to do is take this mixture and suction filtrate it, collect our crystals, and let them dry off.
Here we have our organic layer, and we mix some HCl to make the quinculadine gain a hydrogen to give it the charge and therefore be in the water layer. And then we mix it. Now that we've mixed the HCl with the organic layer, we then pour it back into the separatory funnel. Then we pour out the water layer with the conjugate acid, the organic layer, and the camphor on. Then we do another HCl treatment and separate again and ensure that the interface goes with the organic layer.
Okay, so let's add that back. And then we will separate it. Water layer, organic layer.
Now that our conjugate acid is separated from the camphor, we can turn it back into the original base. We will once again use an ice bath, but we will slowly add NaOH to basify the compound. Once again, we will get a permanent solid, and we will monitor the pH again. We want to get it to at least a pH of 10, or change the pH paper to a dark blue. Once again, we dip the stirring rod into the mixture and touch the pH paper and add NaOH as needed. Then we can suction filtrate our solid and be left behind with the crude base of quinacridine. We could have recrystallized it to get pure crystals, but the crude solid looks pure enough. After we have gotten both our pure acid crystals and our crude base crystals, we should do a TLC plate with the eluent being the diethyl ether to ensure that they are pure compounds and do not contain each other.
So here's an example TLC plate where A is our acid and B is our base, and as you can see, they don't contain components of each other. Now we move on to the camphor, which is in our organic layer. We will mix some distilled water into our organic layer and swirl the mixture. Then we're going to pour it back into that separatory funnel. And there's going to be some layers forming. So now we are going to take out that bottom layer, as it is that water wash that we don't need. And then we're going to take out our organic layer from the top. And now with that organic layer, we're going to add some sodium chloride. And this is going to cause some initial drying. Once again, we're going to mix it. And then we're going to add it back into that funnel again. And then we get another 2 layers, and we're going to take out that aqueous layer again because we don't need it. But we're also going to take out the interface because that is no longer needed. And then we are going to take out our organic layer from the top. So now we have the organic layer with the camphor inside. This mixture should not have any drops of water, otherwise we will need to remove them with a Pasteur pipette. So let's remove those water drops. Now we can add some granular drying agent, and we're going to swirl that around so that it collects and dries the mixture, separating the water from the organic layer. So we will start to see some of those clumps. And now we have to separate these or filter these from our desired mixture. So we put a cotton ball, and then we're going to draw up the liquid by putting the Pasteur pipette in the middle of the cotton ball. And we're going to draw up that liquid and put it in another container. To actually remove our solvent, we will use a rotary evaporator. Rotary evaporation is a much better way to separate a compound from its solvent than distillation because it is faster for one. It lowers the boiling point of the solvent, and the rotation increases the surface area of evaporation. It is also better than distillation because a lower temperature is used if some part of the mixture is sensitive. In the case where simple distillation, it would negatively affect some compounds if they were sensitive to temperature. And also, the solvent can be reused with rotary evaporation. So now we're going to attach the vacuum and then the flask, and we're gonna make it rotate. And if it starts getting foamy, we could put it in the hot water bath. The solid is collected in the round bottom flask. So now we have successfully separated all 3 of our compounds from each other back into their solid form.